Hi everyone, welcome to my channel. Let's talk about today's LeetCode daily challenge. Today's problem is about bitwise operations, yeah, and it's about and. And the problem is like you are given two integers from left to right. You should AND all the numbers in that range and return the answer. For example, if the first one is 5 to 7, so 5, 6, and 7. Let's take a look at that. 5, 6, and 7. So the first thing that you should think about when you are given a problem that is about bitwise operations, especially AND, OR, and XOR, is to think about the answer in terms of bits. Because the answer for each bit is not depending on any of the other bits. So for example, for this bit, you can just calculate the answer based on the bits in this column. For this bit, you can just take a look at the numbers here and so on. So for example, in this example, yeah. So here, if we want to know the answer for this column, for this bit, which is 2 to the 0, this is bit 0, basically. The answer is 0 because we have 1, 0 in this range. We have 1, 0 in this range. Remember, this is the key. Here, again, we have 1, 0 in this range. It is 0. Here, we don't have any zeros. So the answer is 1. Okay. So if we go back and look at the range of the numbers, first, the range is very big. So it's the maximum integer. It's 2 to the 31 minus 1. And so you cannot do a for loop. What you can do is, if you have seen binary representation of the numbers, you may remember that there is a repetition pattern for each bit. For example, if you look at this bit, it's 1, 0, 1, 0, 1, 0, 1, 0, and so on. If you look at the first, like bit 1, this is bit 0. If you look at bit 1, it's 1, 1, 0, 0, 1, 1, 0, 0. So the period length here is 2. So the first one is 2 to the 0. The length is 1. 2 to the 1. The length is 2. 2 to the 2. The length should be 4. Let's take a look. So here we have 1, 1, 1, 1, and then 0, 0, 0, and 0. You see, the length is 4. And 2 to the 3, the length is 8. Okay. So that means if, for example, if the total numbers that you have from left to right is greater than 8, is greater than 8. So for example, if you have 10 numbers, so I'm going to call it total count. And that would be right minus left plus 1, right? This is the total count. So if the total count is greater than 8, what does that mean? That means in this range, from left to right, you will definitely have at least 1 0 for bit 3. So for bit 3, yeah. So here, for example, it goes from here all the way to here. And you will have 1 0 here. These two are 0. And it doesn't matter how you move this, like where you pick your 10 numbers. If you have 10 consecutive numbers, there is at least 1 0 for bit 3. This is the key. All right. So if this is the case, that bit is definitely 0. But otherwise, if total count is less than this period length, let's say, for example, it is 4. Now we know 4 is less than 8. So now it depends. It depends. Where is that 4 starting? Like, where is the left and where is the right? So if it's here, from here to here, like this one, this one, this one, and this one. So you see that here we have 1, 0. But if that one is from, for example, here to here, we see that all of them are 1. So 1, 1, 1, 1. So how do you find out? So in order to check this, you just need to check L and R. Why? So if you're checking bit I, you just need to check if left has that bit and if right has, that bit. That bit is set for L and R. Why? Because if these two are 1, like if this is 1 and this is 1, definitely anything in between is 1 as well. Because it's not possible that you have 1, 1, and then you have a bunch of zeros, and then you again have a bunch of 1s. It's not possible. Why? Because of this condition. We have already checked that from left to right, we have less than or equal numbers of 2 to the I. And 2 to the I is the length of this period. So for example, from left to right, if there are less than or equal to 8 numbers, it is not possible to have a few 1s and then a few zeros and then a few 1s, because this itself, these zeros itself is 2 to the I. While we know, we have already checked that from left to right, it's less than or equal to the I. So it's not possible to have 2 to the I number of zeros in between this left and this right. So you just need to check this bit and this bit from left and from right. Okay? So let's go and see how we can write the code. So I need some variable to keep count of the total numbers. So int total count is going to be right minus left plus 1. So here you should be careful not to get overflow, because if right is 2 to 31, then this is going to be 2 to the 31 plus, 2 to the 31 minus 1 plus 1. And if left is 0. So in order to prevent that, we will use unsigned integer. And here we will cast right to unsigned integers, so we will not have overflow. Then we need some variable for the result. And then we just need to do a for loop. So B should go all the way up to 30, because 2 to 31 minus 1, that means all of the bits from bit 0 to bit 30 are set. That number is 2 to 31 minus 1. So we go all the way from 0 to 30 for bits. And then we have int period length, which I'm going to call period length. And it's going to be 2 to the bit. 2 to the bit. That is it. And then here we check if total count is greater than period length. Okay, that means that we definitely have a 0 for this bit in this period. So we continue, and here we just check the left and right. So if has bit B and left and has bit B and right, if both of them have this bit, I'm gonna add that bit to result. So result is gonna be ORed with 2 to the B. And I need to add this function, which is very simple. I just need to check and see if that number has this bit. So return to the bit, and we will AND that bit with number. So if the answer is greater than 0, that means number has that bit, and we will return true as a result. And then here we just return result. So this is our code. And let's run. And here we have 3 greens. Submit. So that's it. So as a follow-up question, think what will happen and how our solution will change if we are going to do OR instead of AND. Think about it. Thank you.